I'm Rhett Jesse, and today we're going to talk about one of the main features of our digital proximity system. We can actually trim a cable and then reconfigure our DPS to the length that you want. Most proximity systems, they come in 5 or 9 meter systems. But in the field, it makes it difficult on installations. You'd like to terminate the cable to the actual length you need. Aesthetically, it's not very pleasing. It's really the last cabinet you want to open for anybody at the plant to show them how nice your cabinets look. But this gives you the ability to trim those and to actually make it work. So what we can do is we can go in and take an extension cable, or actually a probe cable as well, and we can trim it to the length we want it to. And then we can reconfigure our digital proximity system, whether it be our driver or our transmitter, to the length that you have. Now, the lengths are in 1 meter increments. What this video is for is to show you how to trim and then put a new connector on. So that's what we're going to talk about. All right, so to do this, we're going to use our MX8020 cable connector and trim kit. Inside the kit, we have a number of tools. We have instructions on how to do this, and you can find this on our website too, by the way. We have the crimpers that we'll use to crimp the connector on, and this includes the pin and the body of the connector. We'll use those. We'll also use the wire strippers. I use these to cut the cable as well, because these are pretty good jaws for cutting through the entire triaxial cable. And then we'll use this for stripping the wire as we need to. And then we have some very good right angle cutters. And then we have a wire cutter. This is to cut the triaxial cable, and you'll see that when I do this demonstration. You also have connectors that come with the kit. 10 come with the kit, and you can get a connector refill kit, so you don't need to keep buying the tools. You can just buy the refill kits, and the refill kit has these connectors in it, as well as shrink tubing in order to finish the connection after you put on the connector. And it has the kit has a blade, and the blade I've already put inside the cutter. So with that, we'll go ahead and I'll show you how to cut a cable and put on a connector. And so that's what we're going to talk about. I'll go ahead and get these DPS units out of our way. And you need, from the kit, we have a piece of shrink tubing. We have a outside body of the connector. We have the pin of the connector, and we have a ferrule that will go on that the pin, and it will be crunched by the body of the connector. So we have all the pieces that we're going to need to make this connection. So the first thing we're going to do is we're going to simulate cutting off some cable. And let's just say I'm cutting off a meter, 1.8 meters of cable. So we'll go ahead and make that cut. Now, I would advise you, after you've cut this off, if this is your first time putting on a connector, don't try to put the connector on their finished wire. Practice on the wire you cut that you're going to throw away. So you want to at least practice 1 or 2 times so you get the hang of it, and then you'll be a professional and you'll have no problem doing this in the field. All right, so we've cut our cable, and we were simulating this as 1.8 meters long. All right, the next thing we do is we take out our wire cutter. Now, what this is for is to basically trim back the triaxial cable. The triaxial has a stainless steel underneath it. It's very difficult to cut through. You're not going to be able to do it with wire strippers. You'll just mess up the cable and you'll never get there from here. So it's very difficult to get through that triax. So for that, we give you a wire cutter. Now, this wire cutter is special in that it's actually a triple blade cutter, but I only use a single blade. And I use the blade that I'm going to cut farthest, my farthest cut, and it's just for cutting through the triaxial cable and possibly the plastic that covers the coaxial cable underneath it. So what we're going to do is we set the wire in there, and when we put the jaws forward, it will engage the blade. And if I have it set right, it will cut through exactly what I need to cut through. If you cut through deep, you'll go through the center conductor and you'll have to cut it again. If you cut it too shallow, you're not going to get through the stainless steel, and you're not going to be able to remove the triaxial jacket. So what you do is you set the blade, and I've got it pretty well set for this. And then after you engage it, you'll hear it cutting as we move it. It's probably way too much. And I'll go around until it stops cutting, and then I'll inspect and say, oh, I've cut way too deep. So I want to back out this setting, or what I can do is move it back one mark on the bottom, and I can see if I cut it any better. There's a Allen wrench onto the side that you can use to adjust these blades. So I can adjust the blade depth here, but I'm just going to use this setting to see if I just get a little bit closer on this next cut. You want about 2 millimeters sticking out from the tool, and then you want to engage the blade. That's 2 millimeters, a little bit less than 1/8. It doesn't have to be perfect. In the instructions it has exact measurements, but as long as you get close, you're okay. Alright, so before I move much further, I'm going to put on my safety glasses, so that way I don't get anything in my eyes, and plus it has some glasses, they're bifocals, so I can actually see very clearly. Doing this work, if you can't see the threads of the shield, the individual threads, your eyes are not good enough. So you have to put on glasses. Alright, and you want to wear safety glasses anyway. Mine have bifocals so I can see the individual threads. And I can see, okay, I've made a pretty good cut. So what I'm going to do is I'm going to use these strippers, and I'm going to use the 10 gauge, and I'm going to engage right where I cut, and I'm going to try to pull off that triaxial shield. Okay, and I've made a pretty good cut, and I've removed the triax. So that's what you want to be able to do. And I've left on the plastic shield. Now I've cut through it just barely, and that's really what you want. You really don't want to cut through the coaxial shield that's going to be part of our electrical circuit. So you want to not cut through it, but you want to cut through the plastic that's on top, and we cut that perfectly. That's a nice, it came off very easily. So, and that's really due to I can see the work. If you can't see those individual threads, you have to put glasses on that you can actually see with. So that's important. All right, so we've removed the triax. Now we have to remove the plastic, and that is the 14 gauge. So you put on the 14 gauge, and you really don't have to press down really hard because you don't want to cut the coax shield. You just want to pull off the outside casing, or the vinyl, and so that clear comes off, and now we see the secondary, or the coaxial shield, and we'll be able to start working with that. Okay, next move is to put on the shrink tubing, because once we put the connector on, you won't be able to do that. So go ahead and put the shrink tubing on and move that down your cable and get it out of the way. The next thing we do is we put the ferrule on. The ferrule has a thick portion, it's thick here, or it has the thin side. The thin side is going to go on the pin, so the thick side goes away from the connector. So basically you want to put the thick side towards the triax. So there's the thick side, and I'm going to put it onto the cable just like that, and it will stop at the triax just like that. So that's where you begin, and now we're ready to start moving towards putting on the connector. So the next thing we do is we basically pull out this the shield on the coaxial cable. We just want to fan that out, and I pull on it, and you spread it out so it makes it easier to cut, and it also makes it easier to engage on the pin. So you want to pull that out so it looks like that when you're done. So you have it to where it's easily, you can cut through it. And this is pretty strong stuff too, but it's not as strong as the stainless steel, so we're going to use just the sharp cutters to cut this. So what we're going to do is use these wire cutters, and we're just going to trim off the excess. I leave about maybe a millimeter next to the ferrule, and I just cut that extra off around it. And then I go in and I pull it out a little bit more. Just make sure I try to get engagement with all the threads on the pin, and you'll see why I need that here in just a minute. But I want to trim off most of it, and and get it so that I have a nice circumferential shielding around it when I put the pin on. But what I do next is I want to mount the pin so that I get engagement with that shield, that shielding, and I don't extend the wire goes inside the pin, but I also get good engagement. So you've got to look at that and say, okay, I've got to take off about 6 millimeters, about 1/4 of an inch of center conductor. So I'm going to go ahead and do that, and you do that with the 22 gauge. I probably took off a little bit more than what I needed, but that's okay. I'm going to twist this so I can put it inside. I might trim it up too in just a minute. Then I want to look and see what kind of engagement I'm going to get with the pin and the conductor. Okay, so the center conductor is a little bit too long, and I'm going to get just about the right engagement, so that's pretty good. So I'm going to shorten the center conductor by about 1/16 of an inch, 2 millimeters. That looks pretty good. What I want is that center conductor to go inside this pin. There's a little window in the pin that when you have the center conductor in it, it will turn from gold to silver, and you'll see that right here. So right now it's gold, and when I put the wires inside here, it will turn silver, and that way I know that the center conductor wires went inside the pin. I'll put this on. When you put it on, if you just lightly touch it and then you basically twist it, the wires will go in pretty nicely. And what you'll see is you'll see the silver show up because you have the wires inserted. And that's important because we're going to crimp that once we have the ferrule onto the pin. Now you'll notice what we have is the coaxial shield here. It wants to go on the outside of this pin, and that's where we make the connection. So I want to hold the pin firmly in place, and I'm going to push this onto it. And I didn't get a very good bite. Okay, so what I'm going to do is I'm going to push this back down and spread this out a little bit. I'm going to take off a little bit of this, the insulator that's around the primary conductor. I'm going to take off a little more, so I'm going to use my 22 gauge and just cut it back a little bit. Alright, now we're able to put this pin back on, and what I'm trying to achieve is I want to make sure I have the center conductors going inside the pin. I look at the window and they're there, and I want good engagement with regard to those threads. And if I don't get that here, I'm not going to get a good connection. And you can tug on it a little bit, and I'm still not satisfied with that, so I'm going to bring it back just a little bit more, make it a little bit better. To do that, I'm going to trim off just now. It's down probably to a 32nd, now 1/2 millimeter. It's really small, but that's where it needs just a little bit of detail, and you'll get the feel for it. But you do want that shielding to go on the outside of this, not quite to the edge here, because you can't have any of the threads sticking out. If any of the threads are sticking out, it won't work. So you've got to make sure the threads are underneath it, but at the same time engaged with it, so they can't be short either. So it does a little bit of art with this, but if you take your time, you'll see that it works. So let's go ahead and put this back on. Okay, I have the silver showing up through the window. Looks like I have good engagement with the ferrule. That's really nice, and I can feel it. You know, you can feel the strength. So I'm going to use these wire cutters, or the wire strippers, as a stop. Put it in the locked position, and then you basically push it on. You can wiggle it a little bit, but there's enough force to get pretty good engagement. So now what we're going to do is we're going to crimp the pin onto the center conductors, and to do that, what I'm going to use are these jaws, and there's a very small hole. It's a round hole. It's 0.041 inches, 41 mils, and the center conductor is going to go inside there, and you can see you can't put the center conductor in it, so it's going to slightly crimp the center conductor to the pin, but you can't really put any force on it. It's just the electrical connection. Okay, so this is not going to bear any load. It's just what we're going to use. To crimp it. Now you want to make sure you have good alignment and you're centered in that hole, so when you bring it down and crimp it, you get a nice crimp. That looks good. Now we want to put on our case for our connector. So we'll go ahead and put that on, and you put that on. As you push it on, you might have to use the stop again to make it work, but I don't have to. It goes on pretty well. If you have any thread sticking out from that connection where the ferrule was, that's going to make it very difficult to put this outer casing on. When you have threads sticking out, use these right-angled wire cutters and get it very tight and cut all those off, so it's easy to put on the outer jacket. Okay, so it's nicely engaged. What we do now is we want to crimp it. Okay, now what we're going to use to crimp it is the 0.178 hexagon that we have here, and that's going to be used as our crimp. So it's actually the second hexagon in the tool, but it's the 0.178. And we're going to open this up, and what we do is we put the connector inside, and we put it up to the ridge, and the ridge in the connector is right here. It makes a little ridge here. It's right over the ferrule, so we really want to crimp the connector just over the ferrule that we put on. So we'll put this inside here, we'll line it up, and then we get it to where it's pretty well engaged. Then you can use both hands if you need to go ahead and squeeze and crimp it all the way down until it releases. Then it will release, and that's a nice crimp. Then I'll be able to take this, and I should be able to pull on it without removing it. Okay, now I'm putting on a lot of force right now, probably about 40 to 50 pounds of force, and it's not coming off. And that's what you should have. It should work like that. So that's good. So that's a nice connection. All right, now we'll go ahead and put on our shrink tubing, and to do that we'll go ahead and shrink this on using our heat gun that we have from the plant. And once it's heated up, you say, okay, I've made a nice connection there. That looks good. But we're not quite done yet, because now we want to check the electrical connectivity from end to end. We want to check for continuity to make sure that we have an electrical connection from the cases and the center pins. So to do that, I'll use a voltmeter. Go ahead and set the voltmeter to ohms. Go ahead and connect common and the voltage leads. Go ahead and take off the pins, and then I'll check for electrical connectivity. First we'll do the cases. Okay, and on the voltmeter, what you'll see is when I have open, and it's open, it's in overload. Okay, when I short it, okay, it's 0. So that's what I like to see. Now, since I'm going through wire, I will have some ohms from end to end, but it should be a very small amount. When I go from connector to outside connector, of course, that's going to be, that's a short. Okay, but when I go from the connector to the pin, I don't want an electrical connection, and I don't have one. I'm touching the center pin exactly, and I have it on the casing. So I don't have any connection between the center pin and the casing, and that's what you want. You want it like that. But then you want to go from end to end. So from casing to casing, that's one part of the signal. And here we have a, it's shorted, a small amount of resistance. And then we want to go from pin to pin. Now this is a little more difficult just because if you're working by yourself, or if you have somebody else, they can get the pin. But if you hold it like, you can use one hand to hold, and then you can use one hand with one pin. And the other hand with the other pin. And you can check for continuity. So I go to overload to almost a short. So that's perfect. All right, so what we have is we have connectivity where we want it, we have continuity, and now we're ready to recalibrate the DPS to the length that we cut it to, and we can test it to make sure we have a nice linear system. So thank you very much for watching this video.